friends, my name is Untitled. Hope you have enjoyed my previous videos. Today I am going to post my next video on a class 10th maths topic, that is derivation of curved surface area, total surface area and volume of frustum. Before going into the derivation, I will first let you know what is frustum. For knowing frustum, we will take certain examples of frustum. Shape of glass of drinking water or shape of bucket used in the washroom are some of the basic examples of the shape of frustum. So friends, as you know, this is the shape of a glass with which we drink water or the shape of a bucket which we use in our washroom. So this is the basic example of frustum. The shape of frustum is like this, in which the upper circular portion is larger in diameter and the lower circular portion is smaller in diameter. This is larger in diameter and this is smaller in diameter. And if you will invert it, it will look like this. This one and this one. Thus, both are same. This is the straight one, and after inverting it, it looks like this. So this is the shape of a frustum. After knowing what is frustum and how it looks like, now I will let you know how a frustum is obtained. Firstly, we will consider a right circular cone. In this cone, as you know that AC is the height of cone, BC equal to CD is the radius of base of cone, So this is the radius of cone and this is the height of cone and this one is the slant height of cone. AD equal to AB, slant height of cone. Okay. Now we will draw a line parallel to the base of cone. Let EF be the line parallel to BD, which is the base of right circular cone. Now, friends, as you can see now in this figure, there are two cones. AEF is the smaller cone and ABD is the larger cone. After drawing a line EF parallel to BD, we have obtained two cones. First one is AEF, which is the smaller cone, and the second one is ABD, which is the larger cone. We will remove this smaller cone by cutting from the bigger cone. After removing this smaller cone, we will obtain two figures. After removing smaller cone from bigger cone, we will get two figures. The first one is this one, A, E, F, This is the smaller cone which is obtained by removing it, and the remaining one E, F, D, V. Thus, after removing the smaller cone from the bigger cone, we obtain these two figures. This is the smaller cone, and friends, you must have identified this figure. This is the shape of frustum. In this way, a frustum is obtained by cutting a smaller cone from a bigger. After knowing what is frustum, how it looks like, and how it is obtained, we will switch on to the derivation of CSA, TSA, and volume of frustum. So this is the diagram which will be used in the derivation. Now I will signify all the notations related to this diagram. So friends, these are the different notations related to this derivation. Eg equal to Gf, as you can see, this is the radius of small cone, which is designated by the symbol R1. Bd equal to Dc is the radius of the big cone, which is designated by the symbol R2. Gd is the height of frustum, which is designated by the symbol small h. Eb equal to Fc is the slant height of the frustum, which is designated by the symbol small l. AB equal to AC is the slant height of the big cone, which is designated by the symbol capital L. AD is the height of the big cone, which is designated by the symbol H. AG is the height of the small cone, and AG can be calculated by AD minus GD. By inserting the symbols of AD and GD from above, we got AG as capital H minus small h. And what is AG? AG is the height of the small cone. The last one, 1 is A. A is the slant height of small cone, as you can see from the figure. And what is A? A is AB minus EB. By inserting the values of AB and EB from above, we got A equal to capital L minus small l. And A is the slant height of small cone. So friends, these symbols along with these notations will be used in the derivation. Now after drawing a diagram and signifying all the notations used in the derivation, we will start our derivation. First of all, we have to consider two triangles AGF and triangle ADC. So I am considering triangle AGF and triangle ADC. In these two triangles, angle AGF is equal to angle ADC because these are corresponding angles. Similarly, angle AFG will be equal to angle ACD because they are corresponding angles. Why they are corresponding angles? As you know from earlier that EF is parallel to BC. As EF is parallel to BC, so in ADC and AGF, we have considered the two triangles. GF is parallel to DC. As GF is parallel to DC and AD is acting as a transversal, so angle AGF will be equal to angle ADC and angle AFG will be equal to angle ACD because both pair of angles are corresponding angles. So by AA similarity, triangle AGF is similar to triangle AD. So both the triangles are similar. As two triangles are similar, so AG by AD will be equal to GF by DC will be equal to AF by AC. This is due to CPST. What is CPST? Corresponding parts of similar triangles. So as two triangles are similar, so by CPST I have got the ratio of the respective sides equal. Now, from the figure I will insert all these values. AG is the height of small cone, which is h minus h. AD is the height of big cone, which is capital H. GF is the radius of small cone, which is R1. DC is the radius of big cone, which is R2. AF is the slant height of small cone, which is capital L minus small l. And AC is the slant height of big cone, which is capital L. After inserting all the symbols from the figure, firstly we will compare h minus h upon h with R1 by R2. Firstly I will consider this one, and secondly I will compare R1 upon R2 is equal to L minus L upon capital L. So in the next step I have to compare these two. So in order to proceed further, I will rub all the things. My last step was I will have to compare two things. The first one was h minus h upon h is equal to R1 upon R2, and the next one was L minus L upon L is equal to R1 upon R2. So by cross multiplying this, I will get h minus h into R2 is equal to h into R1. HR2 minus HR2 will be equal to HR. Now, by shifting capital H R1 from right hand side to left hand side, I will get HR2 minus HR1, and I will shift this one to right hand side. It will be positive HR. By taking capital H common from these two things, I will get R2 minus R1, and here the matter will be same, that is HR2. So the value of capital H is HR2 upon R2 minus R. Similarly, from here I will cross multiply it. So L minus L into R2, which will be equal to L into R1. I will open the bracket. LR2 minus LR2 is equal to LR1. I will shift LR2 to right hand side and LR1 to left hand side. LR2 minus LR1 will be equal to LR2. This was positive here. By shifting to left hand side, it will become negative. This was negative here. By shifting to right hand side, this will become positive. From these two, I will take capital L common, that is R2 minus R1 is equal to small l R2. So the value of capital L will be LR2 upon R2 minus R1. So we have got the value of capital H in terms of small h, R1 and R2. I have extracted the value of capital L in terms of small l, R1 and R2. So friends, you must be thinking that why I have extracted the values of capital H and capital L only from these two equations. I must have extracted the values of small h or small l or R1 or R2. The basic reason behind this is I am deriving the different formulas of Frustum. So in the formulas of Frustum, only the parameters of Frustum will be considered. And what are the different parameters of Frustum? The first one is small h, which is the height of Frustum. The second one is small l, which is the slant height of Frustum. And the R1 and R2, which are the radius of the upper and lower circular portion of the Frustum. Except these values, no other parameter will be involved in the different formulas of Frustum, that is CSA, TSA and volume. And you can see in this equation and this equation, only capital L and capital H are not involved in the different parameters of Frustum. So I do not need the value of capital H and the value of capital L while deriving the different formulas of Frustum. That's why I have extracted the values of capital H and capital L from these two equations, because capital H and capital L are not involved in the basic parameters of Frustum or in the formulas of CSA, TSA and volume of Frustum. Now friends, I will start with the derivation of the formula of curved surface area of Frustum. For use in the side, I will write values of capital H and capital L because it will be used in the derivation. Now I am deriving the formula of curved surface area of Frustum. Curved surface area of Frustum. So the CSA of Frustum will be CSA of big cone minus CSA of small cone. Because Frustum is this one, E, F, C, B. So the CSA of Frustum will be obtained by subtracting the CSA of big cone ABC and CSA of small cone AEF. The curved surface area of the CSA of cone is pi r L. So the CSA of big cone will be pi, the radius of big cone is R2 and the slant height of big cone is capital. CSA of small cone is pi, the radius of small cone is R1 and the slant height of small cone is capital L minus small l. Insert value of capital L equal to LR2 upon R2 minus R1. Because in the formula of CSA of Frustum, there is no involvement of capital L. So after inserting the value of capital L, we will get LR2 upon R2 minus R1. In place of L, I have placed it. And similarly here also, LR2 upon R2 minus R1 minus L. In place of L, I have placed this. After this step, by opening the bracket, we will get pi L R2 square upon R2 minus R1. And in this, first we will take LCM of these two, that is R2 minus R1. It will become LR2 minus L into R2 minus R1. Solving further, we will get pi R2 square upon R2 minus R1 minus pi R1 into LR2 minus LR2 plus LR1 upon R2 minus R1. Plus LR2 and minus LR2 will get cancelled. Then we will proceed to next step. I will write this, then I will write that pi LR2 square upon R2 minus R1 minus pi R1. It will become LR1 upon R2 minus R1 because these two are cancelled. Next, pi L R2 square upon R2 minus R1 minus pi L R1 square upon R2 minus R1. From these two, we can take pi L upon R2 minus R1 as common. After taking common, we will get R2 square minus R1 square. So pi L upon R2 minus R1, this is A square minus B square, which is A plus B into A minus B. So these two get cancelled. And the final formula is pi L R1 plus R2. Thus, this is the curved surface area of frustum. In order to calculate CSA of frustum, we will use this formula in which pi is a constant, L is the slant height of frustum, R1 and R2 are the radius of the bases of upper circular portion and lower circular portion. After deriving the formula of curved surface area of frustum, I will switch on to the formula of total surface area of frustum. Total surface area of frustum. The total surface area of frustum will be equal to curved surface area of frustum plus area of upper circular portion plus area of lower circular portion. So in TSA of frustum, the CSA of frustum will be included, and along with CSA of frustum, the area of this circular portion and the area of this circular portion will be included. The CSA of frustum was pi L R1 plus R2, which I just derived it. The area of upper circular portion, the area of this circle will be pi R1 square, and the area of this circle, that is the lower circular portion, will be pi R2 square. So this is the formula of total surface area of frustum. Total surface area of frustum. After deriving the formulas of curved surface area of frustum and total surface area of frustum, I will derive the formula of volume of frustum. Volume of frustum. Volume of frustum can be derived by big cone and the volume of small cone. Just as we derive the formula of curved surface area of Frustum. So, the volume of a right circular cone is 1 by 3 pi r square h. So, the volume of big cone will be 1 by 3 pi. The radius of big cone is r2. So, it will be r2 square, and the height of big cone is capital H. The volume of small cone, that is 1 by 3 pi. The radius of small cone is r1. And the height of small cone is capital H minus small h. I will insert the value of capital H, which is equal to HR2 upon R2 minus R1 in the above equation. By inserting the value, I will get 1 by 3 R2 square. In place of capital H, I have inserted this value HR2 upon R2 minus R1 minus 1 upon 3 pi R1 square. In place of capital H, I have inserted the value HR2 upon R2 minus R1 minus small h. I have inserted this value of capital H in this equation here and here. Now I will open the bracket. It will be 1 by 3 pi h r2 cube upon r2 minus r1. Here first I will solve the bracket. The LCM will be r2 minus r1. So it will be hr2 minus h in bracket r2 minus r1. Then 1 by 3 h r2 cube upon r2 minus r1 minus 1 by 3 pi r1 square hr2 minus hr2 plus hr1 upon r2 minus r1. I have opened this bracket, it will be minus hr2 and it will be plus hr1. These two will get cancelled because this is positive and this is negative. Now I will proceed to the next step. For that I have to rub it off. I will not rub the last step because it has to be used. First I will write 1 by 3 pi h r2 cube upon r2 minus r1 minus 1 by 3 pi r1 square hr1 upon r2 minus r1. And these two are cancelled. Now I will rub it off. I will open the bracket. R2 cube upon R2 minus R1 minus 1 by 3 pi h R1 cube upon R2 minus R. From these two, I will take common 1 by 3 pi h upon R2 minus R. After taking this common, I will get R2 cube minus R1 cube. So this is 1 by 3 pi h r2 minus r1. I will apply the formula of a cube minus b cube. So what is the formula of a cube minus b cube? A cube minus b cube is a minus b into a square plus b square plus a. By applying this formula in this, I will get r2 minus r1 into r2 square plus r1 square plus r1 r2. This bracket, this is of no use. So by expanding a cube minus b cube, I got this. Now r2 minus r1 will get cancelled. So the final formula is 1 by 3 pi h r1 square plus r2 square plus r1. So friends, this is the formula for calculating the volume of Frustum. Now I will write all the three formulas which I have derived, that is curved surface area of Frustum, total surface area of Frustum and volume of Frustum. CSA of Frustum. The formula which I derived was pi L R1 plus R2. TSA of Frustum. The formula which I derived was pi L R1 plus R2 plus pi R1 square plus pi R2 square. And the last formula was the volume of Frustum, which I derived as 1 by 3 pi h R1 square plus R2 square plus R1. So by this, friends, I have derived all the three formulas of Frustum, that is curved surface area of Frustum, total surface area of Frustum, and volume of Frustum. This is a most important derivation in the class 10 maths chapter surface area and volume, as you will get this question in the NCERT optional exercise of surface area and volume chapter. By this, friends, I think you must have liked this video of mine. See you soon with some interesting topics of class 9th and 10th maths and physics. Thank you.